What if one of the most promising candidates for extraterrestrial life in the entire universe just got the most powerful radio scan in history, and scientists are still not sure what they found? Right now, 124 light-years away, a planet called K2-18b orbits a red dwarf star in the constellation Leo. It's a world unlike anything in our solar system, with a thick hydrogen-rich atmosphere that may surround a global ocean of liquid water. And in July 2026, astronomers did something unprecedented. They pointed two of the most powerful radio telescopes on Earth at this single planet simultaneously for an unusually intensive search. The question isn't just what they found, it's why they looked in the first place. Let's start with the numbers, because they explain why K2-18b has become the most closely watched exoplanet in the search for extraterrestrial life. The planet lies approximately 124 light-years away. It orbits within the habitable zone of its star, meaning temperatures could allow liquid water to exist on its surface. Observations from the James Webb Space Telescope have revealed an atmosphere rich in carbon dioxide and methane, making K2-18b one of the leading candidates for what astronomers call a Hycean world. A planet with a thick, hydrogen-rich atmosphere that may surround a global ocean of liquid water. I'm the host here at Today Latest Analysis, and every claim in this video comes from actual published research, including a paper in the Astronomical Journal, not exaggerated headlines or unverified speculation. Subscribe now and turn on notifications, because the search for life on K2-18b is far from over. Let's start from the beginning, because to understand why scientists pointed the world's biggest radio telescopes at K2-18b, you need to understand what makes this planet so extraordinary. K2-18b was first discovered in 2015 by NASA's Kepler Space Telescope, but it wasn't until 2023 that the James Webb Space Telescope turned its powerful instruments toward this distant world and revealed something remarkable: the presence of carbon-bearing molecules, including methane and carbon dioxide, in its atmosphere. Even more intriguing, Webb's data suggested a possible detection of a molecule called dimethyl sulfide, or DMS. On Earth, DMS is produced almost exclusively by living organisms, primarily marine microbes such as phytoplankton. That detection was tentative. Scientists urged caution, noting that the signal could have other explanations, but the possibility that K2-18b might harbor life, microbial life, producing a chemical fingerprint in its atmosphere that we could detect from 124 light-years away, was too significant to ignore. In April 2025, researchers reported possible traces of DMS and/or dimethyl disulfide in the planet's atmosphere, chemicals associated with biological activity on Earth. Media coverage was extensive. Here's the part of this story that almost no coverage explains properly, and it's the part that matters most. The radio survey of K2-18b wasn't looking for the same thing Webb was looking for. Webb was searching for chemical biosignatures, the atmospheric fingerprints of biological activity. The radio survey was searching for something entirely different: technosignatures, the artificial radio transmissions that an intelligent civilization might produce. Because of its potential to host conditions favorable for life, K2-18b has become a prime target for the search for extraterrestrial intelligence, or SETI. Researchers recently used two of the world's most powerful radio telescopes to search the system for signs of artificial radio transmissions. The project combined observations from the Carl G. Jansky Very Large Array, VLA, in New Mexico, and the Meerkat radio telescope in South Africa. Coordinating facilities of this scale for a single observing campaign is highly unusual, and provided an exceptionally sensitive search of the K2-18b system. Now here's the second layer of this story, the part that shows just how sophisticated this search really was. The telescopes didn't just point and listen, but they used advanced software systems to process an enormous volume of data. Radio telescopes are constantly flooded with signals produced on Earth, everything from cell phones to satellites to radar. Astronomers rely on sophisticated software to identify and remove interference before searching for anything unusual. For this project, the VLA used the Commensal open-source multi-mode interferometer cluster system, while Meerkat relied on the breakthrough Listen User Supplied Equipment, BLUES system. Scientists then applied 5 separate screening methods to search for possible technosignatures. The first was radio frequency interference masking, which removed signals within frequency ranges known to be heavily contaminated by human-made transmissions. Researchers also accounted for the Doppler effect. Radio signals traveling between planets should exhibit measurable Doppler shifts as the source and observer move relative to one another. Any signal showing essentially no Doppler change was considered almost certainly to have originated on Earth and was discarded. Another filtering step removed signals with signal-to-noise ratios below 10 or above 100. This helped eliminate extremely weak false detections, as well as unusually strong instrumental artifacts. However, The authors note that this choice could also have excluded some genuinely weak extraterrestrial signals. The team also performed multi-beam analysis, creating multiple focused beams with one directed at K2-18b and another aimed elsewhere in the sky. A genuine signal from the exoplanet would appear only in the beam pointed at K2-18b, while interference from Earth would generally show up across multiple beams. The final planned screening method involved transit filtering. A signal originating from K2-18b should disappear when the planet moves behind its host star. Because no such secondary transit occurred during the observing campaign, this final test was not needed. So what did they find? Their findings, published in the Astronomical Journal, found no evidence of narrowband radio signals comparable to technology currently used on Earth, despite identifying millions of possible candidate signals during the observations. The coordinated VLA and Meerkat campaign sifted more than 20 million radio detections logged while watching the K2-18 system and found nothing that came from the planet. But here's the critical nuance that most coverage misses. As one researcher explained, we did not conclude that there are no technosignatures associated with K2-18b. The researchers were clear that their search was limited by the assumptions they built into their screening methods. The search from 544 megahertz upward, the signal-to-noise thresholds, the Doppler criteria, all of these choices could have excluded a genuine extraterrestrial signal if it didn't fit their expectations. One of the researchers also noted that if an extraterrestrial civilization happened to transmit within frequencies already heavily contaminated by human-made transmissions, detecting it would likely require a radio telescope located somewhere free from Earth's radio noise, such as the far side of the moon. In other words, we might be broadcasting so much noise that we're drowning out any signal that's out there. It's worth being direct about what this survey does and doesn't prove. It does not prove that K2-18b is lifeless. It does not rule out the existence of a technological civilization on or around the planet. What it does is demonstrate a powerful new approach to SETI searches that will make future surveys faster and far more effective. The project showed that coordinating two of the world's most powerful radio telescopes for a single campaign is possible and valuable. The data processing systems worked, the screening methods were effective, and the search itself was the most sensitive ever conducted for this target. The researchers published their findings in the Astronomical Journal. The paper details how the search was conducted, what was found, and what the limitations were. It represents a significant step forward in the methodology of searching for extraterrestrial intelligence. So here's what this actually means. Once you separate the confirmed findings from the speculation, we know that K2-18b has an atmosphere containing methane and carbon dioxide. We know that Webb data suggested a possible detection of dimethyl sulfide, a molecule associated with life on Earth. We know that astronomers conducted an unusually powerful radio survey of the planet using the VLA and Meerkat simultaneously. We know they found no evidence of artificial radio transmissions, and we know they processed more than 20 million radio detections in the process. What we don't know is whether K2-18b actually harbors life. The DMS detection remains tentative. The radio search found nothing, but absence of evidence is not evidence of absence. The planet remains one of the most promising candidates in the search for extraterrestrial life and future observations. With Webb, with radio telescopes, and with new instruments not yet built, we'll continue to probe its secrets. I'll bring you the next update the moment any new observations of K2-18b are published, whether from Webb, from radio telescopes, or from future missions. If you want real scientific discoveries explained accurately, separating what's actually confirmed from what's still speculation, that's exactly what we do here every single time. Drop a comment and let me know what part of this surprised you most. The fact that DMS was detected in the first place, the scale of the radio survey, or the scientists' honesty about what they still don't know. Like, subscribe, and turn on notifications so you don't miss the next update, and I'll see you in the next one.